Yeah, so before going through MapReduce and bulk synchronous system, let's go through some basics. So we'll start with what is a graph. So graph is basically a non-linear data structure. It consists of vertices and edges. As you can see, these are the vertices or nodes, and the link between them are known as the edges. And these are few examples of the graph. For example, we have the hyperlink structure of the web, and then the physical structure of computers on the internet, and then the interstate highway system, and the social networks. And let's go through a few graph problems. For example, let's see, find the shortest path. So the shortest path, nothing but the shortest path between two nodes. Example would be routing internet traffic and the UPS trucks. And next is like finding the minimum spanning tree. Minimum spanning tree is nothing but finding the subset of edges which connects all the vertices in a graph. Example would be the telco laying down fiber. And then next we have finding maximum flow in a graph. An example would be the Arling scheduling. And then we'd go through identifying special nodes and communities in the beginning of the class. An example would be like breaking up terrorist cells and to see how the flu is spreading in a community. And then the bipartite matching, example would be monster.com and match.com. And obviously the page rank, how ranking the web pages in the web based on the query given by the user. And so we have different ways to process the graph data. Because of the size of the graph data, they often require usage of parallel processing for efficient computation. We're going to see two techniques here. One is MapReduce, one is bulk synchronous systems. So we'll start with the MapReduce solution. So this MapReduce, it helps in decreasing the communication and movement of large data. So let's just consider an example of join, where we join two tables, RAB and SBC. So in semi-join process, what it does is, it first finds all the B in S and maps only those elements from R which has a corresponding B in S. So if at all we don't have a corresponding B, it won't send it to the reducer path. So if most of the records in R do not have a corresponding B value, it will save substantial communication. So one more question would be, what do you think the difference between natural join and semi-join?
Difference between natural join and semi-join.
What are we saw this is semi-join? What do you think the difference between this and the natural join?
Natural join is always done through a common field between the two tables.
Yeah, even here we have the difference is that it will process all the elements in R to the reducer phase. But here it only processes the elements which has a corresponding B value. That's the difference between semi-join and natural join.